Alright, welcome to some requested episode. I think it's the 7th. Yeah, it is the 7th. And this is going to be about characters that follow waypoints in a specific order requested by Booball. So let's go ahead and get started. It's going to look something like this, just to get you a little taste of it. And as you can see, there is just this kind of sprite here that is always following these waypoints. They can change and change, and he's always following them. Also, I can take the first waypoint of the path and move it around, and he will always follow them. So he's, live updating to the new position of the waypoint, which makes the whole thing rather stable. Alright, so let's get started. So at first, we need to create a new class. This is in my project, as you can see. It doesn't matter in which project you do this, so I'm just taking this project here. And I create a new class called Waypoints Tutorial or something. Who gives a crap? The superclass, the interface is going to be screen. There we go. And this thing is going to have a sprite badge to actually render this sprite on. So private sprite badge equals new sprite badge. I can't type today. In this post we're gonna dispose this badge, and in height we're gonna dispose. Then in show we also wanna say gdx.gl.gl clear color is black, and in render we wanna clear the screen with gdx.gl.gl clear gl 2.0.gl color buffer bit. Then we wanna batch.begin and batch.end, so we can draw stuff in between. But right now we don't have anything to draw, so let's get some stuff to draw. What do we want to draw? We want to draw all the characters of this, all these characters that we're going to make that follow waypoints. So we are taking an array of these characters. So how we're going to call them? I don't know. AI sprite or something. It's not really AI because, I mean, they're just following waypoints. It's not this intelligent, but who cares? I tested it with this name. I'm not going to continue with this name. So there we go. We obviously have to create this array. So AI sprites equals new array of AI sprite. And then we have to create this AI sprite class. This is going to be in the entities package. Who cares what package you put it in? It's your decision. And it's going to extend the sprite class. So now let's set up the basic stuff that we need to even be able to follow a path, and that is obviously the possibility to move. So to move, I have already shown you a couple of times. We use a vector2 called velocity, which initially is going to be a new vector2 with 0, 0. So what is a vector2, in case you're watching this and never watched anything that I made before? A vector2 is just holding an x and a y value. That's actually really it. You're going to see it's really simple. Then we also want a float variable called speed, which just indicates how many pixels per second we are going to move. 100 is pretty fast, but I don't know. It's good. The next thing that we need to follow a path is obviously the path. So we want an array of vector2s. They can be used as velocity or they can be used as points, because points are made out of x and y, which is exactly what vector2 holds. I'm a huge fan of those. And that's going to be called path. Also, nope, not yet. Let's import this array class and create the constructor of the AI sprite. it's going to take a sprite, so to set up all the basic stuff, and it's going to take an array of vector 2's again, which is going to be the path. So at first call the superconstructor sprite, and then this dot path equals path. And I really can't type at all. Okay, so now that we have this class at least existing, let's actually continue with it. So the difference between this sprite and the normal sprite is that this sprite can move, and to move we need to update its position. And to do that we need something that is continuously called, which in the case of the sprite is the draw method. So before we actually draw, we want to update. And you're probably familiar with this. We give it the gdx.graphics.getDeltaTime, which is just the time between the last frame and the current frame. So let's go ahead and create this update method, public void update, float delta, and there we go. This update method is where all the interesting stuff is going to happen, and I don't know why this is still not satisfied. Update, update. What's your problem? Did I spell it wrong or something? Oh, I spelled it wrong down here. Okay, so this is where all the interesting stuff is going to happen. At first, we want to start with some really interesting, or rather confusing stuff, which is going to be the math to get the angle and the velocity on both axes to actually move to the next waypoint. So the first thing that we need is to know which waypoint we are currently at. And this is what I wanted to add before. Just a simple int, which is going to be called, let's call it waypoint. So this waypoint, usually you'd think you just told us waypoints are an x and a y value, and this is in vector 2. But yeah, this is true. But this is an int just because it's the index of the vector 2 in this path array. It's just, you could also do it a different way, but I think this is pretty fine. Alright, so the first thing that we want to calculate is the angle between the current position and the position of the waypoint. Yeah. This is going to be a float called angle, and now is where the confusing math stuff comes. At first I need to cast a float. This is going to be math.a102 and taking a double y and a double x. The double y is supposed to be the distance of the current position to the waypoint position, as well as the x. So it's always supposed to be the distance on that axis. How do we get the distance? We take the waypoint and subtract the current position from it. So how do we get the waypoint? Remember, I just set up this waypoint variable. Correct. We go to path.getWaypoint dot y, because in this A102 y comes before x. Don't ask me why, I don't know. And we just subtract get y from it. The same for the x. Path.getWaypoint dot x minus get x. Alright, so this looks rather confusing, but it's all fine. Actually, let me just call it 0 here, because we always want to start at the first point in the path, obviously. So yeah, that makes sense. Next, we want to set the velocity according to this angle that we just calculated. There's also math stuff going on in this one. So velocity.set, taken the x and the y value that we want to set to the velocity, and this is also, we have to cast this to floats, and you see Eclipse is already making fun of me. Floats. Alright, so this is going to be math.cosine, and we put the angle in there and take this times speed. I'm going to explain why in just a second. Math.sine on the y-axis, okay? Don't mess this up. Cosine and sine. Angle times speed. So what's with this cosine and sine times speed? So probably if you remember from school, cosine as well as sine returns a value between 0 and 1. That's already in your calculator, but also we got it here. So this can be 0 or 1 times speed. So the maximum on one axis that we can how fast we can be is speed, which is just how it's supposed to be. We can't get over speed. We can just get lower than speed. So this is actually the max speed value. But in the end, if cosine here returns something like 0.9, sine is probably going to return something like 0.1. So these two are always going to add up to speed, so that in the end we always are as fast as speed tells us to be. Alright, so why does this return something between 0 and 1? Imagine here this is the x-axis, and if we have a point that's right there, and the other point is the waypoint where we want to go is right there, these two are on the same x value, okay? So if they are on the same x value, we don't need to move on the x-axis at all, we just need to move downwards on the y value. So cosine is going to return 0 times speed, so that on the x-axis we are going to be, 0 fast. Therefore sine is going to return 1, because we want to put all the speed that we have onto the y-axis. I hope that is enough of explanation for that. Let's go on with actually setting the position according to this velocity that we just calculated. To do that, we use the setPosition method of the sprite and say the current position, this time on the x-axis, plus velocity.x times delta. The same thing for the y-axis, get y plus velocity.y times delta. So what did I do just here? We're taking the current position, adding the velocity on 1, but times delta, so that we always have the same speed across all frame rates. You should be kind of familiar with this. It's pretty much the same in all the leading game engines and frameworks, whatever, like LibGDX. Alright. Then we also want to set the rotation to the angle, because the angle is the angle between the current position and the waypoint position. So it makes sense to set the rotation of the sprite to that. It makes it look more realistic. We don't have to, but we want to. One thing to notice is that the angle is returned in another unit. It's the radians unit. It's returned in radians. And radians are obviously something different than degrees, so we have to convert them. This is simply done in LibGDX, because there's this class called mathutils, and this contains a field called radians 2 degrees. Or if you want to make it short, reddec. I don't really care what you use. I don't actually care what you do with the code at all, but radians 2 degrees is simpler to read. Anyway, so this is it for the AI sprite for now. Let's go and set it up so that we can actually see if what we are doing is leading to anything. Here we see our constructor. It's taken a sprite and the path, which is an array of vector 2's. So we need to create some AI sprites with exactly that. At first, let's just create one AI sprite that we're going to add to this AI sprites array. So AI sprites dot add new AI sprite, taken a sprite and a path, which we are going to get from getRandomPath. Doesn't exist yet, so don't wonder what's going on there. Sprite is going to be a new sprite, new texture, image, this is just some random image that I got in this project, and it's pretty visible on this background, so let's use it. This sprite is going to be declared up here, because we just have it once, and we want to dispose it. Sprite.getTexture.dispose. Alright, so now this getRandomPath. Actually, no. At first, the sprite should be not a scale, I'm sorry. Set size should be 50 by 50, because otherwise it's just plain too big and makes no sense at all. And I want to set the origin of it to 0, 0, so we can exactly see where it's actually at right now. And it's always going to return around its bottom left corner, so yeah, we can just perfectly see where the sprite is currently walking around. Then for the getRandomPath method, which we have to create, it's going to return an array of vector2s, which is just the same thing as right here, an array of vector2s which we use to store the path. This is not going to return null, of course, but instead a path variable, which is an array of vector2 path equals new array of vector2. Alright. Then we want to put some random values in there. So let's get for loop 0, I smaller than, and now let's get some random stuff. There's also the math utils again, which provides us with a random method, which we can give a start and an end value. So let's say we want between 5 and 10 waypoints in this path. Then I++. And then we just have to go ahead and say path.add a new vector2, which is taking an x and a y value. So for x, let's get math utils.random again, random, and this is going to be between 0 and gdx.graphics.getWidth, which is just from the total left of the screen to the total right, so anywhere on the screen. Obviously on the y-axis as well. So math utils.random 0 gdx.graphics.getHeight. This is just a point anywhere on the screen. So we're going to add 5 totally random points to this array of vector2s, which is the path, return it, pass it into the iSprite constructor. So it's going to end up right here and everything is fine. Then we also want to draw all these AI sprites. So for AI sprite from AI sprites, AI sprite should be drawn on the batch. So I want to remember you that this .draw method actually calls this update method, which is where all the stuff is going on. Okay, fine. Is there anything else that we want to do? Not for now. I think we might actually be able to run this already. Don't kill me if we get a null pointer exception or something. And oh, this is totally the example that I showed you before. Let me just change this to Waypoints tutorial and not just the test of it. And yeah, there we go. So he's slowly walking towards this one waypoint that we defined, but he never stops doing that. So you can see he always walks to a different waypoint and always starts in the bottom left corner there. But that is not very interesting. What's that actually? So there he's going and going and going and going. Boring. Let's spice this up. Okay, so at first, to actually have an idea what we're doing and not just do stuff in the darkness, let's draw the path of the AI sprite to the screen. To do this, we are going to use a ShapeRenderer right there. Private ShapeRenderer. Let's just call it SR for simplicity. Go down here and create it. SR equals new ShapeRenderer. And we want to dispose it as well. SR.dispose. This ShapeRenderer here is going to do some stuff. So for each AI sprite from AI sprites again. We want to draw. So what do we need to draw? To draw the path, we need 2 points. One waypoint and another waypoint to draw a line between them. So at first I want to get one waypoint called previous, which is going to equal AI sprite dot get. There's one method missing. I'm just going to. What did I just? What am I going to? To add this? No, not really. I'm just going to add this method here, GetPath, which is a simple getter that returns the path. You should be familiar with getters. And yeah, GetPath dot first. So this is going to return this previous one is going to be the first waypoint in the path. Then for vector2 waypoint from AI sprite.getPath, we want to actually draw it. So we want to call sr.begin with the shape type line, because we want to draw a line, and sr.end. In between here we can draw all kinds of lines. So sr.line from the previous waypoint to the current waypoint. The first time this is executed, this is going to be from previous to the first one again, but who cares, we are just drawing a dot, who cares really. But all the times after that, we want to set previous to waypoint. So the next time this is drawn, previous is the waypoint that we just draw and that we just drew, and the waypoint is the next one. Alright, also just because we can, let's go sr.begin shape type.filled and sr.end and sr.circle waypoint.x waypoint.y and 5 pixels radius. So at every waypoint we're going to get some kind of circle, just because we can. Let's try this out and see if it looks better than it just did. So we can see, we already see the path that this thing is going to take. Right now we just see it's passing over there and then going crazy up there. Why is it going crazy up there actually? Oh yeah, sure, it's always trying to go to the waypoint. So if it's already at the waypoint, it's just circling around the waypoint all the time. And yeah, it starts in the bottom left corner and then goes to the first waypoint. And yeah, there's the path that we just created with the getRandomPath method. Okay, so this is still not very interesting. At first, this thing is hacker slow. Let's make it 500. And actually, probably you remember that blue line that we had, so let's get it again. sr.setColor color.white, as it has just been, and sr.setColor color.cyan, sr.begin shape type.filled, sr.end, sr.line, new vector2 AI sprite.getx, AI sprite.getY to waypoint. So this is just going to draw this blue line that we had previously, that goes from the AI sprite to the waypoint that it's currently walking to. If we don't get some nasty exception. Why the hell did we get an exception there? Oh, filled? No, it's actually line. That's it. So now we're going to get this blue line. Okay, that is a lot of blue lines. I'm sorry, not for every waypoint. We just want to do that for one waypoint. Actually, there. Let's do it there. And separate this a little bit so this looks a lot better. and it's going to AI Sprite dot get path dot get AI Sprite dot get waypoint, and this AI Sprite dot get waypoint still does not exist. So let's go here and create this getter again for waypoint. And now this is going to work. If it's not going to work, I'll have to cancel this whole series. Okay, it's actually working. Yeah, there you see it. It's drawing. Fine. Rup. And actually we want to draw these AI sprites before, so they are always updated correctly. And alright, that's it for the boring stuff. Let's go into the update method and do the more complicated stuff. So that is, right now we are going to the waypoint. How long do I record already? Holy shit, this is going to be a long episode. Thanks for still watching this. Now we want to actually get the AI sprite to go from waypoint to waypoint, and not just to go from where it has been to the first waypoint and then get stuck at it. To do this, we need to switch the waypoint variable once we reach one waypoint. So we want something like if is waypoint reached I think that's actually enough, isn't it? Wait, let me just have a real quick look. Yeah, that's actually fine. Is waypoint reached? We wanna do stuff. At first, let's create this is waypoint reached method, and for now, let's just sys out I'm there. Yeah. Public void is waypoint reached, and not void, actually boolean. This is going to return if the let me just explain the concept. We have one tolerance variable that we declare up here. Tolerance equals 3. And this is the number of pixels that we have to be close to the waypoint to say we reached it. So if we are 3 pixels close to the waypoint, we reached it. Do you remember this here, where we said the current waypoint minus the current position is the distance? Yeah, I hope you do, because we are needing that right now. So path.get waypoint dot x minus get x. This is the distance between the current position and the waypoint. If that is smaller or equal to tolerance, we say we are there on the x-axis, but we also have to be there on the y-axis. So path.get waypoint dot y minus get y smaller than or smaller or equal to tolerance. Okay. And what is this guy's problem? Add return statement. There is a return statement right there. Thanks. Okay, so this looks confusing and whatever, but it's basically just getting the distance and seeing if it's smaller than the tolerance. So alright, this is when we say the waypoint is reached, and let's try out if this is actually working. He's going there, he's going there, he's going there, and there. Oh yeah, I'm there, awesome, it's all working fine. Alright, so in case we reached the waypoint, we don't just want to say that, we actually want to switch to the next waypoint. So we would just think waypoint plus plus. So that's the index of the path array that we are considering the current waypoint. But this is going to get us some problems, and I can actually show you that right now. Yeah, he's going to the next waypoint, that's all fine, and then what is this? A crash. index out of bounds exception, because we just have 5 waypoints, but we are trying to assess the sixth one. So we want to just check if waypoint plus 1 would be greater or equal to path.size. Then we don't want to do this. Then we just want to set the waypoint to 0, so we start at the beginning again. But else we want to increase waypoint by 1. This should totally work fine. We are going there, we are going there. What is this? Ooh. We are going there, 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 there, and no crash. We are returning back to the first position and walking the path all over again. This is actually it already. Really. But now this is not perfect, or yeah, it's not perfect. Let me just show you real quick. If we increase the speed to something like 2000, bam, we have a little problem. Do you probably see that if he gets here, he doesn't start from the waypoint position, but he starts from a little bit more on the top and then goes to that waypoint. That is because in one time step he is so fast that he just runs over this waypoint and yeah, is at some other position than the waypoint. This is easy to fix, though, really easy to fix. So if the waypoint is reached, actually, what did I do? I'm sorry. If the waypoint is reached, we wanna set the position to path.getWaypoint.x and path.getWaypoint.y, so you can start waypoint.y, so you can start all over to the next waypoint clearly again. And you see we don't have this problem anymore. But you can see we have another problem, and that is, did you just see that? He's sometimes stuck at a waypoint and like going all crazy around it. This is because in one time step he is so fast that he is more farther away from the waypoint than our tolerance variable is. So he has to go to the left of the waypoint, to the right of the waypoint, and all around it until he finally reaches a position that is near enough for the tolerance. That is a little bit harder to fix, but also possible. To do this, we just have to go into the isWaypoint Reached method and say the tolerance should not be this fixed. It should be the... Actually, I have to look this up, I'm sorry. Okay, or fine. It should be the current speed divided by tolerance. So we have some relation between speed and tolerance, and this times gdx.graphics.getDeltaTime on both axes, of course. Speed divided by tolerance times gdx.graphics.getDeltaTime, which means we are taking the speed, in this case 2000, divided by tolerance, which means a tolerance until part of the speed, which in this case is 3, because we set tolerance to 3. So let's actually get this calculated. 2000 divided by 3 makes 666 times gdx.graphics.getDeltaTime, which is usually something like 0.016, and we see because he is so fast it just needs to be 10 pixels, because he easily exceeds the 10 pixels limit. And now if we see this, we have to save first. Now if we see this, we see that he's not going crazy at all anymore. And if we select another speed, All this stuff is because it's divided by tolerance and times GDX graphics get delta time. It's adjusted, so for the speed 100, it's also working fine again. Let's get some path. We don't have to wait this long, because this is fine. And jump, jump. There we go. There we go. He's totally perfectly walking that path. Alright, so at first I want it to be something like 900. And then let's add some more of these AI sprites, and then we're actually done with this episode. AI sprites.add should be done for a couple of times. Int I equals 0. I smaller than mathutils.random. We want between 5 and 10 AI sprites. I++. Also, we want the AI sprite to be at some random position on the screen, so let's take it out of this. Edit AI sprite equals stuff. AI sprite dot set position with our awesome mathutils.random method again between 0 and gdx.graphics.get width. Also here mathutils.random 0 gdx.graphics.get height, and that is it. Yeah, that's actually the whole freaking series tutorial. Just want to see how this looks. Yeah, we got a bunch of sprites going all crazy. Obviously we cannot really see what's going on, but we know that it's doing the job correctly and they're not interfering with each other or anything. So I hope this episode helped you, and helped you to implement this kind of path following. I don't know if it's an artificial intelligence or not. I don't really think so, but this path following robots or whatever to your own game. For example, in a maze where the player has to get through, there are enemies that are following these waypoints, and if the player meets one of these enemies, he's dead. Whatever, you're the programmer, you can do awesome stuff with it. Go ahead and do awesome stuff with it, and I'm hopefully going to see you in the next tutorial. Thanks for watching, and yeah, goodbye.